a wild thing. We are going to be learning some wild things in this chapter, but it's all groovy. Welcome to the Johnson Kendra Video Hour.
But it's not an hour.
Oh, bumper drag. All right, section 5-2, polynomials and linear factors and zeros.
Okay, we're going to start by talking about the two forms of polynomials. The first form that we're going to talk about is called factored form. It looks like a polynomial that's been factored. That's exactly what it is. It has parentheses. Yeah, it's factored.
All right.
Okay.
Factored usually means parentheses somewhere.
Right. If you want to write it in standard form, which is your other form, these are the two we have, you would just have to multiply that out. You'd have to FOIL this and simplify, and then FOIL that to the next set of parentheses. If you want to go the other way, for instance, if you start with standard form and go to factored form, you just have to factor. So we're going to do some factor review right now. We're given some polynomials. They are given in standard form because there's no parentheses, and we want to write them in factored form. So you need to use all the stuff we've learned about factoring to decide. Remember, it's always helpful to look for a greatest common factor. We do not have one here, and it's a 1 out in front. So I'm ready.
Makes it easy.
Right. I'm ready to go right to the parentheses. Some of you love 4-spot method and want to do that anyway. That's fine too. It's going to be an x and an x. Because it's a minus, the only way to multiply to get a minus would be 1 positive and 1 negative. And then I need factors of 10. Kendra, go!
10, 1, 5, 2.
And which one do I want?
I want 5, 2, 5, 2.
5, 2. That's it. That's factored form of that polynomial.
All right, so let me get this straight. So like 2 and 5 are factors of 10. Then these two are factors of that.
Exactly.
Okay, I get it.
All right, next one. At first I was nervous when I saw this because I thought
There's so many x's.
Right, x to the third.
But they each have one.
So that means it's a GCF. So you'll make your life easier if you take that out of there. Divide, each of those by x. That will change the polynomial to this. But we're not necessarily done. We got to keep on going. Again, I've got a 1 out in front, so it's x and x. Since it's a plus, it's either plus plus or minus minus. We're choosing minus minus because of this. Factors of 49. Go!
1, 49. 7, 7.
Gotta be 7, 7.
Gotta be. That makes 14.
Yep, those are the same. So you can actually write it like this. It's called the perfect square trinomial. And later on, we're going to talk about how this factor has a multiplicity of 2.
Ooh, that's a cool word. Multiplicity.
Multiplicity. Wasn't that a movie? They're probably too young for that.
Maybe. I think I'm too young for that. Hey, look at that one's weird. It's only got 2 things to it.
It's only got 2 things. When we did these, we talked about maybe a greatest common factor, but I don't think that they share one. It actually is our special case that we learned. It's called a difference of squares. It's subtraction, and both terms are perfect squares. So when we factor that, we square root each thing to decide what goes in the parentheses. Square root of 49x squared is 7x. That's going to go in our first places. And then square root of 4 is 2. For there to be no middle term, the signs must be opposites.
Because they'll cancel out.
That's the quick way to do it. Some of you like to put a 0x in the middle and do it the long way. That's okay too.
Yep.
It'll just take a little while to get there. So, all right, moving on. Why do we need to factor these things? Well, they're going to help us find the zeros.
The zeros are when y equals 0, so it's basically where it crosses the x-axis. So x-intercepts are kind of the zeros. Some math books call them solutions, some call them roots. We're calling them all 3, so you got to get used to that. So we find the zeros by setting each factor. Remember, factors are in the parentheses. We set each factor equal to 0. So let's figure out what are the roots. Okay, we've got x plus 1, x minus, or plus 2, and x plus 3.
That's in factored form.
It is, because it's in parentheses. All right, so we're going to take each of these and set it equal to 0. X plus 2 equals 0, and x plus 3 equals 0. First thing you always do, subtract 1, so I get x equals negative 1. Subtract 2, x equals negative 2. Subtract 3,
Negative 3.
x equals negative 3. All right, so we found the zeros. The next thing we have to do is find the degree and leading coefficient, and there's a shortcut way to do that.
Wait. To find the degree and the leading coefficient, I thought it had to be all FOILed out in standard form.
Well, that's where the shortcut comes in.
Okay.
And so we don't have to FOIL all this and then multiply that by x plus 3. We're going to think about x times x, and then if I take that and multiply it by this other x, I will have x to the third, and the number in front will be a 1 because all the x's have a 1 in front.
So the rest of the equation doesn't matter?
Not for what we're going to do, not for our graph.
Okay, that's why it's a shortcut.
Yep. So we have to pay attention to that 1 and that x cubed. All right, so we have to plot the zeros. So those are the numbers I found up here. So I plot -1. You get down here a little bit. -1, -2, and -3. All right, we did that. Next one. We have to determine the end behaviors. That's where this comes into play here. Right here. We have to look at that. We have an odd exponent. Odd means you're going to have one up and one down. And this is positive. The 1 is positive. That means we're going to rise at the end. And then the graph does whatever it wants in the middle. So for this one, we're going to rise at the end. And the odd means we have one of each. One down, one up.
Did we learn that in the last lesson?
We sure did.
Okay, got it.
Hopefully we learned it.
Got it.
All right, so I'm going to do my rise up here and start down here. And then I'm just going to finish the curve. I'm going to go up, down, and through. And we just finish our curve. And then multiplicities we already talked about, but we're going to get to those in a few minutes.
No, wait a minute. How do I know? What about this graph? Maybe it goes like really high, really low. How do I know how big to make the things?
Well, we're just getting a general shape. We're not going to worry too much about how high and how low, just to know that that's where they go through.
So we're just sketching.
Just sketching.
General shape.
Right. We would need a graphing calculator to get it perfect.
Okay. All right, so now we're actually going to kind of go backwards here. We're going to start with the zeros, and we want to write the factors, and actually we want our final answer to be in standard form, so we're going to do lots of FOILing. So I have 4 zeros here. That means that I'm going to have 4 factors. Remember, you always come up with the opposite sign. So when you see -2, -2, what we need in the parentheses is +2. That 0 creates this factor. And then we'll do it again here. This will be x minus 2. I've got an x minus 3. That's from this one. And then one more x minus 3. What's that called?
Multiplicity.
It's called a multiplicity. Technically, that could be written like this, but we're going to have to FOIL it anyway, so we might as well leave it out there.
All right.
Okay, so we need to write it in standard form. We got to multiply these things together. So I'm going to do these two together and these two together and then FOIL those all together.
Okay, this is going to be a big, long, honking equation.
I'm going fast. X times x, x squared. X times -2.
-2x.
2 times x.
2x.
Last times last.
-4.
Okay, if I simplify that, that is x squared, cancel, cancel, -4.
Nice.
Okay, so that takes care of these two things. Now I'm going to move on and do these two things. So I have x times x.
X squared.
X times -3.
-3x.
-3 times x.
-3x.
Last times last.
+9.
Those don't cancel. They're like terms. So we got x squared minus 6x plus 9, but we're not done. We have to have no parentheses. So FOIL really doesn't work anymore, but we're using the same concept. X squared times x squared.
X to the 4th.
X squared times minus 6x.
-6x cubed.
To the 3rd, that's right. And then x squared times the 9.
9x squared.
Next one.
-4x squared. Plus 24x. And -36. Ooh, that's getting pretty big.
Like terms, I only have 1x to the 4th. That takes care of that. I only have 1x to the 3rd. That takes care of that. But I do have like terms here. That's going to give me 5x squareds. And no more like terms, I don't think. So 24x minus 36. This is my polynomial in standard form.
That's a wild thing.
It is. You can check your work. We ended with x to the 4th. And the reason is because
there are 4 zeros.
There are 4 zeros. Okay, I had a couple hints I wanted to tell you about over here. Multiplicity, the graph acts differently when a multiplicity happens. And remember, we had that here because these happen twice.
This kind of reminds me of a parabola.
Right. And what that means, when when you have an even multiplicity, so an exponent of 2 or an exponent of 4, whatever, that means a bounce.
Kind of like a parabola bounces. It's
Right.
a big curve.
That's a great way to think about it. And later on, we're going to talk about odd multiplicities. It doesn't count to the first, but if it were to be to the third or above, what happens then?
Those kind of flatten out before they cross through.
Okay, so a bounce means that it's going to hit the point and bounce right back up.
Uh-huh.
And a flatten means that it kind of does like a little squiggle before
Right.
it goes through. One other thing I wanted to give you as a hint, because you're going to see this, what if one of the zeros is 0?
Huh.
So we were supposed to set up the factors with x minus whatever or x plus whatever, but if you're not adding anything, really you can just put an x out in front of what other factors you
Okay.
have, so it's just distributed.
So that would cross through the 0 on the graph.
Right. Okay, last thing we're going to do with this equation, I actually, just for extra practice, we're going to do a graph for this one as well. So remember, in the very beginning, I was given the zeros. They were -2 and 2, and then 3 happened twice with an even multiplicity.
Okay.
So we need to know that. So for our graph, and I'm just going to do a very general shape, I put the zeros on, so little dots at those intercepts. And then remember 3, I'm going to put that one in a different color because that's the special one. +3.
Right, it's got 2 answers there.
And we need to think about foiling it out. Well, guess what? We already did FOIL it out. It's right here.
Okay.
Okay, so we have y equals 1, x to the 4th, and yes, we got other stuff. We need to know that the leading coefficient is positive, so that means that we end up. And this time the degree is even. That means they do the same, so up and up. And you might be tempted to go through, and through, but if you did that, you would end back down again. And what's going to happen, the special point, my green point on there, that's the bounce that happens. So we're going to go through, and then what happens on the green is it just bounces right back up. And that's because of the even multiplicity that happens.
So it doesn't go through there, it bounces back up.
And if you didn't do that, there would be no way to go through those 3 dots and get your stuff to connect. You'd go through this and end back down. So we need that bounce to make that happen.
Very cool.
All right, last topic.
All right, multiple zeros. Here we're going to just find the zeros and state any multiplicities. We're not going to graph these. So finding the zeros, we set each part equal to 0.
And they already have it factored for us.
Isn't that nice? So 5x equals 0, divide by 5, so I get x equals 0. So
a 0 is 0?
Right, our graph is going to go through 0. Then I have x plus 2 equal to 0, x equals -2, but because of that, I really have 2 answers. So after this, we're going to say a multiplicity of 2.
So the multiplicity of 2 comes from the exponent of 2.
Right. This has a multiplicity of 1, but we don't usually say that because it's just implied if it doesn't. So those are the zeros. But make sure you include the multiplicity for any that have an exponent with it.
But we don't need that.
We don't really need this, no. All right, let's look at one more. So I'm going to take 5x minus 1 equals 0. So I'm going to move the 1 over and divide by 5. So I get that. Is there a multiplicity with that one?
It's a 1, so we don't need it.
Right, so we don't have to. And then I have x minus 1 equals 0, so x equals 1. Is there a multiplicity?
Yes, it happens 3 times, so
All right.
multiplicity of 3.
So we just can say mult 3. Abbreviate, mult 3.
That looks great.
All right, we'll see you guys later.
Wild things.